So here's our fraction that we've got to integrate, and remember that we know that it can be split up into two separate fractions that can be done very easily. The question is, how do we get back to there? So what the start point is that we say that this fraction can be written as some number over one factor plus some other number over another factor. These factors underneath are found by factorising that expression, that quadratic expression. The two factors, we have 2x and x in here, which are your two, because remember we have to multiply out these brackets to get back to here. So 2x times x gives us our 2x squared term, and then it's now a question of thinking of two numbers that I can multiply together to give minus 2 and add together to give the minus 3. And if I put minus 2 in here and plus 1 in here, if I think about it, 2x times minus 2 gives us minus 4x, and then x times 1 gives us plus 1x, which gives us our minus 3x, and 1 times minus 2 gives us a minus 2. So it's about looking for the factors, and there's a few ways you can do that. One way would be to just factorise, and that's what I've done there, by inspection. As far as you're concerned for the exam, it will be by inspection, or it will be given to you, if it's to be given to you, but somehow or other we have to factorise it. If I've got an x squared term underneath here, I factorise to end up with the two linear factors. And if we think back to the start of this, remember it's going to end up looking like that. So we've got our two factors now, 2x plus 1 and x minus 2. All we've got to do is try and find out what these numbers are. So what we do is we call one of them A and one of them B. And now we've got to go through a method to try and find out what A and B are. So what we've got is that this expression, minus 3x minus 14 over this, which can now be written as 2x plus 1 x minus 2, equals some number over the 2x plus 1 factor plus some other number over the x minus 2 factor. So we've split the denominator into the two parts. We've factorised to get this, and then we split our two factors, and we've got to find A and B. And the reason why we're doing it, as a reminder, is when we come to the end and we integrate these two, that's easy because we've seen already how to do it. So what we do is, I want to get the denominator on the left hand side to be the same as the denominator on the right hand side. So actually we go back and add these two together. So I multiply these two factors together to get the common denominator that we were looking at earlier. So this equals 2x plus 1 underneath times x minus 2. But what we do is A has got to be multiplied by the x minus 2 term, remember, and B has got to be multiplied by the 2x plus 1 term. So we just combine our two fractions together to get that. So first step, separate into the two separate factors and then recombine them to get this. This means that minus 3x minus 14 over 2x plus 1 x minus 2 equals that. Now we look at this and we say the denominators on both sides are the same. So because they're equal to each other, the numerators must be the same as well. So we equate the numerators. We equate numerators. We say that minus 3x minus 14 equals a times x minus 2 plus b times 2x plus 1. Now we've got to try and find out what a and b are. And to do that we assign values to x. Whatever x is in here, it's the same here. So if I let x take any value at all, minus 3 times x minus 14 has got to equal a times whatever x is minus 2 plus b times 2x plus 1, according to this. So we assign values to x to make life easy for ourselves. If I let x equal 2, 2 minus 2 is 0, and this term disappears. So I'll end up with an equation where I can find b, because b will be the only unknown. And then once I've got b, I let x equal a value so that this bracket is 0. We'll think about that in a minute. And then that means b will disappear and I can find a. So that's the idea. So the first step is to let x equal 2. And we do that so that the term involving a disappears. Letting x equal 2, minus 3 times 2 minus 14 equals a times 2 minus 2, that's gone, b times 2 times 2 plus 1. Now let x equal 2. Let's work out the left hand side. Minus 3 times 2 is minus 6. Minus 6 minus 14 is minus 20. Equals 2 2's are 4 and 1 is 5. 5b. And so b equals minus 4. So I've found one of the numbers in these fractions. I've found this one. Yeah, I know that that's minus 4. And if we think back to the previous slide, that fits in because we've got minus 4 here. So we found one of them. Now what do we do to find the other one? I let equal another value. So I let x equal another value. I let x equal a value so that I'm after one where this is 0, aren't I? So I want 2x plus 1 to equal 0. So I've just got a little equation to solve. Taking 1 over the other side. 2x equals minus 1, x equals minus a half. So I let x equal minus a half and then go through the same process. So would you like to just go back to this equation, this original equation here, and substitute in x equals minus a half so that this term disappears, and find a. And I'll just pause while you have a go at it, and then I'll do it on the board. So I put in x equals to minus a half. So it's just substituted in minus a half, and it's not a bad idea to use brackets, you know, just literally substitute in a number instead of x, and then worry about the signs afterwards. So you get minus 12 and a half equals minus a half minus 2 is minus 2 and a half, which is minus 5 over 2a, or 2 and a half a. So then I divide both sides by minus 5 over 2, and I get a equal to 5. So a little bit of algebra to do in there, and we end up with a equals to 5, and if we look back we can see that we've now agreed with that. So we've got back to our original numbers. We found a and b. So we can say that our original integral, which was the integral of minus 3x over minus 3x minus 14 over 2x squared, 2x squared minus 3x minus 2 now equals the integral of 5 over x minus 2 minus 4 over 2x plus 1. Have I got them the wrong way around? Sorry. So it's 5 over 2x plus 1 minus 4 over x minus 2. So I've used the method of partial fractions to rewrite the fraction like that, and then the answer's easy. We've done it already. The integral is, as a reminder, if I differentiate the 2x plus 1 I get 2, so that must be 5 over 2 log 2x plus 1. Differentiate x minus 2 I get 1, so that's just minus 4 log x minus 2.